Hello friends, analysis of quicksort in the worst case by solving a recurrence equation. So this is the recurrence equation for quicksort in the worst case. So how I got this equation? So let's say this is the array given to us, right? So we assume the first element as pivot. Right? So then in the worst case, all the elements are either greater than pivot or less than pivot. Now here, let's say all the elements are greater than pivot, so they will move in the right part of this array. So I will have partition of this array such that there is no element in the left part and all n minus 1 elements are in the right part. So now we can write the recurrence from this. So time taken to sort the array of n elements, that is T of n, by using quicksort is equal to time taken to sort the left part, there is nothing in the left part, that is 0, plus time taken to sort the right part, that is n minus 1, plus time needed to get this partitioning of this array, that is n. We are comparing every element with pivot so that we'll get n comparisons. So thus we get the recurrence equation for worst case. So I'll read it again. So time needed to sort n elements by using quicksort is equal to time needed to sort n minus 1 element plus time needed to get this partitioning from this array, that is n. Right? So now we'll solve this recurrence equation by using method of repeated substitution or back substitution. So let's substitute n minus 1 in equation 1 in place of n. So if we do the substitution, t of equation 1 becomes t of n minus 1 is equal to t of n minus 1 will be t of n minus 2 plus n minus 1 in place of this n. So we get this. Now we'll substitute the value of n minus 1 in here, right? We'll substitute this value back in here, right? So if you do this substitution, the equation 1 becomes t of 1 is equal to, we substitute this entire equation here, so t of n minus 2 plus n minus 1, we substitute this in place of this, plus this remaining n here. Okay, so equation 1 has become t of n equal to t of n minus 2 plus n minus 1 plus n. Still we have t of n minus 2 in the right hand side, so we will not be able to get the answer to this recurrence equation unless we know the answer to this t of n minus 2. So again we will go to equation number 1 and derive the value of t of n minus 2 from equation 1 by substituting n minus 2 in place of n everywhere. So if we do this substitution, we get t of n minus 2 equal to t of n minus 2 minus 1, that is t of n minus 3 plus n minus 2 in place of n. So we get this equation, t of n minus 2 is equal to t of n minus 3 plus n minus 2. So now let's substitute this equation 4 back in equation 3. So we get t of n equal to, we are substituting this value in here, so this entire value we are substituting here, right? So if we do this substitution, equation 3 becomes t of n equal to t of n minus 3 plus n minus 2 plus these remaining two terms n minus 1 plus n. Okay, still we have t term in the right hand side, right? So if you go on doing this substitution, ultimately the term in the t's bracket will become 1, right? Because every time we are reducing the input size by 1, right? So ultimately the input will reach to 1. So the equation when when our term in t's bracket becomes 1, the equation will become t of n equal to t of 1 plus 2 plus 3 plus 4 plus n minus 1 plus n. So now t of 1 is nothing but time needed to sort one element, that is 1 we all know, and this equation will then become t of n equal to 1 plus 2 plus 3 plus 4 plus n minus 1 plus n, and which is nothing but sum of first n natural numbers